Alright, last thing I'm going to do here is I'm gonna cover some homework problems. Just hit up on a few that I think are key. Alright, so first one that stands out to me, problem 5. Alright, if we convert this, 4 to the x equals 1. Now, this is a rule that I want us to all pick up on at this point and kind of, it's always going to hold true. So I could actually do change of base here. If I have 4 to the x equals 1, I could write this as 4 to the x equals 4 to the 0 power, because everything raised to the 0 power is 1. So in this situation, x equals 0. So a rule that you're always going to have, log of no matter what base of 1 will always equal 0. So that's always going to hold true every single time we do these. Alright, let's see what other ones we got here. Alright, so if we look at problem 10, the first thing I would consider here is that this is actually 2 to the 5x minus 1 raised to the 1/3 power, which I can rewrite as 2 to the 5/3 x minus 1/3 equals 6 to the half x. Alright, so in this situation, I'm trying to work this out so I can get it closer to what we were doing before. So it started off with that rad, which I think might throw some people off. Every rad, just make it into an exponent. So what do I got? 2 to the 5/3 x over 2 to the 1/3 equals 6 to the 1/2 x over 1. Nothing going on there. So if I cross multiply and divide, in this situation, I can get this as 2 to the 5/3 x over 6 to the 1/2 x equals 2 to the 1/3, which would give me 2 to the 5/3 over 6 to the 1/2 to the x equals 2 to the 1/3. Now this is an ugly setup, but this is going to work. So if we gave a log, get rid of that. If we gave a log, moved our exponent in front, x equals log of 2 to the 1/3 divided by log of 2 to the 5/3 divided by 6 to the 1/2, and now give us our final answer, 0.891. Alright, so the key thing there, I don't want people to get scared of the rad. Every rad is just an exponent. Alright, if we look over here, which ones can we talk about? Now, something with 13. Alright, so you covered this all yesterday, but I just want to present ideas that sometimes help me out. A lot of people get thrown off with the subtraction pieces. So one thing that helps me personally is I'd rather deal with addition, so I could just rewrite this as log 2 of 2t squared plus 5 equals log 2 of 11 plus log 2 of 5, which combines to be log 2 of 55. So you don't have to do this method that I'm talking about right here, but I find that people like avoiding working with fractions. So by doing this, now we have it set up log 2 equals log 2, drop the log 2's, and solve like normal. 2t squared equals 50, t squared equals 25, t equals positive negative 5, and they both work. You always got to make sure they work or not. Another kind of crazy idea out there for you. Right here we have log base 10, and we have a 2. So knowing log rules, what log with a base 10 would give us 2? Well, if I convert this, 10 squared equals x equals 100. So if I really wanted to, I could write this as log 100 to avoid having to use the other rule about converting. So I could write this as log 100 minus log of x plus 21 equals log x. I don't like working with the subtraction, so I'm moving it away. Log 100 log x plus log of x plus 2. Log 100 equals log x squared plus 2x, which means 100 equals x squared plus 2x. 0 equals x squared plus 2x minus 100. Oh no, made a mistake. That didn't look like it worked. I forgot the 20. It's 21. There we go. 21x, x plus 25, x minus 4, x equals negative 25, x equals 4. 4 works. Negative 25 can't work because it gives us a negative argument. Alright, any others I think I should hit on? No, still, again, I just wanted to talk about a few problems up there to hopefully clarify some things, give you an extra hint or two about ways to do problems. So, I hope everything's going well for everybody. I'm always here to help. Reach out if you have any questions. Have a good one.